Good afternoon. Welcome to lectures 83 and 84 on thermodynamics of materials. Today we are discussing solution thermodynamics and we will continue with that. But today we will revisit mixing functions because actually in the last class there are some audio problem towards the concluding part of the lecture. So actually I want to revisit this and so revisited. Moreover, I want to clarify some points which I could not complete last day. So mixing functions revisited because there was audio problem. The concluding part. The concluding part of the lecture. Of the last lecture. So we'll try to start quickly and relatively fast move on. So what is this? Let us write down the process once more. Na moles of A pure plus Nb moles of B pure goes to, this is a constant temperature, constant pressure, constant T, constant P process, constant temperature, constant pressure process, and this process is known as mixing process, and this gives what? Na plus Nb moles of solution AB. In AB solution, neither A nor B is pure. So let us call this initial state or unmixed state. Initial state called state 1. State 1, this is unmixed state. And this is final state. Final state. This is state 2. This is mixed state. And not bad, I will actually give you a diagram for this. Quickly, this is your cylinder piston arrangement. You have partition here, Na moles of A pure, Nb moles of B pure, they are taken, and this is under constant temperature, thermostated arrangement. Thermostat, constant temperature, and this is a constant pressure. So state 1. This goes to state 2. State 2 is what? Same pressure, and you have this partition. This is partition. This is partition. This partition snapped. Partition snapped to allow mixing, to allow free mixing, and we have Na plus Nb moles of AB solution. AB solution. And thermostatic arrangement as before, temperature T. This is a partition snapped. Partition is broken. So this is your state 1, this is your state 2. Now what we get? So this actually I have described in the figure. This process, call this equation is 1 because this is our main equation, main process. Now I want to get the change in free energy. I am writing this way: delta G M prime PT. M for mixing, prime for extensive property, and its name should be, I'm writing here, the name should be integral total gives free energy of mixing. M for mixing. This is what? This is nothing but, I would say, this is nothing but the delta G. Delta G PT. Delta G prime PT. What is this? This is also, this is actually free energy change for the process as the system. Integral, this is also delta G prime PT is, so wait a bit. PT 1 to 2 is better. This is what? Energy change as the system moves from, as the system moves from state 1 to state 2. Delta G prime. Okay, this is what? Okay, this is what I would say G 2 prime, delta G 1 to 2, 2 prime PT minus G 1 prime PT. Change in free energies, free energy of state 2 minus free energy of state 1. What is this? Please continue. This is what? Free energy of state 2 is what? Let's write this out. State 2 is what we have? Free energy is Na moles of A, but in a solution state, so we have to write Ga bar, partial molar free energy. So since it is impure, plus NB GB bar is under state 2, okay, PT minus Na GA bar. No, I'm sorry, this is the 2, this is the 1. 1 is the not impure, this is pure. So GA pure means standard state. Pure state is standard state, conventional standard state, okay, we call Raoulsian standard state. So superscript 0 for standard state plus NVGB0 state 1, okay, T under constant temperature. This is what? This continue here, this is Na common GA bar minus GA0 plus NB common GB bar minus GB0. This is also known as Na GA bar M mixing, GA bar M plus NB GB bar M. This I discussed last day. What is the name of this? Partial, or give an equation to this. 2. We'll use this later. This is partial molar free energy of mixing of A. Acha. And this is also, this is similarly partial molar free energy of mixing of B. Similarly, GA bar M, GB bar M, and also wrote here, this is like mixing, this is integral total gives free energy of mixing for Na plus NB moles of solution. If you complete this, so since it is, this is an extensive property. Molar property is intensive property. This is for Na plus NB mole, so extensive property. So this is partial molar free energy of mixing of A, and the other is partial molar free energy of mixing of B. So this again you can write, this is second equation I have given, is Na GA minus GA bar minus GA0 is what? RT ln activity of A plus NB RT ln activity of B. This we have discussed last class and also previously. So RT common, you have Na ln activity of A plus NB ln activity of B. Now we see, since noting that activity of A is less than 1, activity of B is less than 1, both less than 1 in a solution, because they are not pure, okay. Since they are not pure, so call this equation 3. So we get from 3, so delta GM prime, PT is a negative quantity, and hence mixing is a spontaneous process. Hence mixing is a spontaneous process. We discussed this previously, spontaneous process examples. 3 examples we gave in the introduction of this course. One is heat flow down a temperature gradient. Second is chemical reactions, and mixing is these are the examples of spontaneous process. Okay, let me check actually. Okay, now about the spontaneity, let us recall a criterion. Here we actually a little bit digress, but we want to clarify the criteria of spontaneity and equilibrium. Spontaneity and equilibrium. Let us recall the criteria of spontaneity from and equilibrium. Just okay, wait a bit. Acha. Spontaneity also use the term irreversibility. And equilibrium is also reversibility. To clarify our concept of concept clarify concept of the criteria of spontaneity and equilibrium in terms of Gibbs free energy. Spontaneity equilibrium in terms of different forms of criteria, of the different forms of, here I have to write this, of the different forms of spontaneity and equilibrium in terms of Gibbs free energy, of the system, in terms of Gibbs free energy, Gibbs free energy of the system. Okay, G. Start. First is DS universe. ES universe greater than equal to 0. The second law. This is the beginning. The second law. Here you recall this refers to spontaneity or irreversibility. Spontaneity or irreversibility. An equal sign for equilibrium or reversibility. Now recall from this DS universe, or you can write here, or delta S universe. Now this leads to dg prime pt, this dg prime pt is so you can call this actually dg prime pt. Actually, you write this less than equals to 0, again less than for spontaneity, irreversibility, and equal sign for equilibrium and reversibility. This gives dg prime pt by dn. dg prime pt, wait a bit. If I write this, I will bring in prime. From this dgpt we prove this dgpt is dgpt by dn, which is actually we will use this dg prime, same thing, just matter of symbol. dgpt by dn, same. Same. This by this we mean this dgpt by dn this is also known as, this is actually, this is delta g, where delta g, where dn is positive quantity, where dn is positive quantity. Oh, so is delta g, that is I'm sorry, is delta g, dgpt by dn is is delta g, is less than equals to 0. I am dividing by dn, where dn is a positive quantity, and what is this? This is explained in the context of the reaction of any reaction such as A plus 2B goes to 3C, the example that we considered before. So if I actually, okay, fine, very good. So let me show you this. Let us this. So this is our A plus 2B, this is our 3C, and this is the equilibrium point. I will give this. This is NC is moving in this direction. We call this N also, NC. This is G prime PT. G prime PT against N, and this is the right constant pressure, constant temperature process, constant. You don't have to write it, right? Pressure, temperature, constant. So temperature, constant, underline. So this is shown here. This you can write also. Now in this constant, now if you want to use this, you consider a state X. Consider a state X here. X. What will happen? How will apply this? See, dg prime dt is, you have to take a, this is nothing but slope, and which is negative, we see negative. So this gives, so what we get here, dg prime pt, this gives you at this point dg prime pt by dn, which is the slope, is delta g, is negative. As we see, it is negative. So when it is negative, the reaction is see, less than means negative means spontaneous. So reaction will be spontaneous here. Okay. So g prime pt. So this is the condition of okay. So this is actually, we write this as note note here only one state is involved, that is state x, not two states, Question is like what when we take the system at state x, whether reaction will occur or not, whether reaction will be spontaneous. Answer is yes, at this state x reaction is spontaneous. So only one state. Now I will show you actually that other use of this free energy criterion involving two states. Coming to that, that is second one. So this is again two states. And what is this here? What is the delta G? You may note this, not so sure. But then what is the delta G now? We have, but this difference on a same state. How G product minus sigma G reactants. So what is this? If we apply this 3, the reaction being A plus 2B is 3C, I have written here. 3 GC bar in bracket maybe minus GA bar plus 2 GB bar. This is the meaning of this delta G. Okay. So G product and reactant at this state. There is no other state. Question is about the system at this state. So spontaneity in the reaction 2B goes to 3C. This. Now you see another situation, another consideration where I will involve two states. Say I consider this Y. But by the way, one thing, be careful. This G prime PT increasing this way. So that means this is greater value, this is less value, this is still less, this is the minimum. Okay. So say I move from state Y, this point is the X, as I have already, this point is the Z. So I am considering two states of the system Y. In this is not the right, because this is about one state. So I think I can remove this part. This part I should not remove this, because I will continue on this. Little later. So I am removing this, but this figure cannot be removed. Only this part I am removing. So star. Another case. So what is our topic? Our topic was how the criterion of Gibbs free energy are used in different situations. Okay, so here, and what are their significance? So one we have obtained. This is for chemical reaction, and we are got the answer. Another case, if it is asked whether the system, this is the reaction system. The system is the reaction system. Whether the system will spontaneously move from state what y to state z. This is the question. Remember, recall two states involved. Note two states involved. Note two states involved. Only once previously only one state is only one state. This is also free energy use, free energy as a criterion, but two states. Question is whether I can call irreversibly spontaneously move from state y to state z. If it is asked whether the system will move from no two states involved. So here the criterion will be, the criterion is what you follow this delta GPT. Please follow delta GPT is actually let me write delta GPT is actually is what delta GPT or PT prime is also just a matter of expression delta GPT. Then the criterion delta GPT is I'm sorry is nothing but how will get this dgpt less than 0. What it is? Integration dgpt from state 1 to state 2. So what is this for spontaneity? Less than 0. So delta G is negative. The criterion is negative. Now we check this. Now if we check from the figure, we see from figure 1, shall I give you this? From figure 1 we see what? This is delta GPT is dgpt, delta G prime PT is what? What it is actually? Tell me. Is negative. From figure 1 we see this is wait a bit. If I Acha. Figure we see delta G prime is what? Delta G prime PT is nothing but G prime PT what? State 2 minus G prime PT state 1. So this is the so this is what we see already. See delta G is what? Let me write state 2 is what? State 2 is what? State 1 is what? State Y. State Y. State Z, state Y. This is negative. This is also further. If you ask me what is this? What is this? Shall I? What shall I write? Okay, this one. Okay. Writing here itself is what? What is the G prime PT? The meaning of this G prime PT at state 2. State 2 means state J, state Z. State 1, state 2. State 1, state 2. Between this and this is what? The meaning of this is what? G prime is what? Na G prime of the it is made up of the any state is made up of ABC. NaGa varying quantity. NaGa bar plus NbGb bar plus NcGc bar. Okay. This is actually clashing with this but I don't want to disturb this, minus at state 2 minus, repeat this, same G prime in, let us NB GB bar plus NC GC bar, state what? State 1, state y, state y. Now this is the meaning of this, but what is the value of this? We have already seen this free energy is less than this is negative. Is the meaning of this okay is negative, is negative. Let us see if I miss anything here. So we have used here, so repeat, the question is whether system will move spontaneously from this state to this state, state 1 to state 2, state y to state z. Answer is, clearly we see answer is what is this delta GPT is what? Is nothing but G of G prime this state minus G prime this state. Now the meaning of this is this and this, and we clearly see the value, this is negative. So shall I write where? Where shall I write is negative. So here this is underline, this underline this is negative. Hence conclusion is what? Conclusion is what? Conclusion is what? Okay. Shall I leave this at this is this I need. Okay. So I have let me write this here, this side. This is mixing, is it? Just I am actually using this place. So we can say so the move so the process of taking so the system will spontaneously move from state 1, which is state y, to state 2, which is state z. So two questions were different so far, but there are some problem with this I am discussing. And before this, what we have got, this is about delta GPT. This is just delta. This is just delta G. This is actually delta. Delta G. By the way, I forgot to write what is this delta G. You may write this here, like this. The way I wrote this here. What is the delta G here? I wrote here somewhere. Oh, I've written here. What is delta G here in this first case? 3GC bar. So this is one question. Another question. Okay, but use this criterion. Okay, all the time? In all cases? No. There is some restriction about the application. For example, if I the second state not at Z but at Z prime, state Z prime, and this is actually equilibrium state. Achha, I am not writing this now unnecessary. So question, but there is some problem. There is some some confusion here. Let me explain this. Achha, I have to remove some of the lines and then I will write once more. Which one? Again, I am removing this. This part is over. Removing this, I will write this. The problem of the use of this point. Problem the use of delta GPT or delta G prime PT or delta GPT, anything you can write. Don't delta GPT is delta GPT also, which is commonly said delta GPT. With the use of as a criterion. Illustration, example, illustration. Suppose the final state, is not Z, is not state Z, but state Z prime. Z prime. So then what is this? Delta GPT. So again, so delta GPT prime, as we write this, is what? Free energy at this state. Y, delta GPT right here. Y to Z. Y to Z prime. Y to Z prime, not Z is not, but state Z prime. So Y to Z prime we have to consider. Still you can see from the figure negative. So again, so can we conclude that it is the system continuously move from state Y to Z prime? This is negative. This is the criterion. Delta GPT is a criterion I have shown here. DGPT integration, etc. I have shown here. Delta GPT I have removed all maybe. It's okay. I have already explained this. Delta G is negative. It's a criterion as we have already used, but here also use again negative. Is it possible? Now this is not possible. Why? Because system starts go up to this point. It will stop at the equilibrium point, which is the minimum of this curve, equilibrium point. So it will never go to this point. So this process, movement of the system from Y to Z prime is impossible. Although PT is negative. So this is the limit of this. The problem is better, right? Limitations of the use of limitations of the use of delta G prime PT as a criterion. So right here, no, even though delta G prime PT is negative here, the system will never move from state 1, state 1 means state Y, state Y, I am writing state 1, state Y to state 1, it is better, right? State 1, which is state Y, to state 2, which is state Z prime, never, although, because what is the reason? It is better I write here state Z prime here. Give me just one line I can write here. Let me write. Yeah, in this, yeah, here I write and then I will remove this. Yeah, this star. This is This is because the state Z prime is a post equilibrium state, which is state E. Any reaction cannot get past the equilibrium state. Can go past the equilibrium state. What will do? So there is some restriction, but it can wait until equilibrium. You consider from any initial state, any state which prior to equilibrium or including equilibrium also. This is possible. This will move from equilibrium, spontaneous process, or any state before equilibrium, spontaneous. From initial state to equilibrium state, spontaneous. So there post equilibrium states. So this you have to be careful. So this actually, for this reason, actually we accordingly conclude. Let me write this. I have to remove this. Yeah. This. This okay. I'm removing this. I hope you have got this already. I'm removing this. This I have to use. I don't want to disturb this figure because we have to consider other functions from these equations 1, 2, 3, and when this diagram, this sketch will be helpful. So I just conclude this is actually okay. What I said, this is not possible, even though the criterion delta GPT is negative. So this is actually misleading, I would say. So this, for this misleading situation, it is misleading. What I wrote last. So this is misleading info. So we use star this and double star here. Just write. It is better I write quickly. We accordingly infer. So how do we use this delta G? The criterion how we will use. We know as long as this is confined to this domain. Sorry. This domain y to z we can. So this I am writing. We accordingly conclude that the relation delta G prime PT is, again I am writing because this is very common to say. That's, although they want to mean this, but this is the simple way of writing. Less than zero will serve, that the relation will serve as a criterion of spontaneity. As a criterion of spontaneity for a process in which the system moves from a given initial state, initial state to another, from given initial state to a final state. The latter means the final state. The latter must not go past the must not go past the equilibrium state. In other words, that is this final state must be somewhere between the initial state and the equilibrium state. Must be somewhere between the initial state and the equilibrium state. The equilibrium state included. Remember, equilibrium state included. So any state between these two, this equilibrium state included. So this is actually our. Now two more points. Hello. Time. Huh? Passed so far. Okay. So where it is this? Thank you. So I have some time. What is this? And now I think this discussion is over. So this is about actually kind of digress. We have digress because we will use this data GPT we have already used, and we because one state to another state. And this is incidentally the final state is the equilibrium state. So initial to equilibrium. Initial to this is for chemical reaction. So this we can use, and delta GPT has been shown to be a negative quantity. Hence the mixing is a spontaneous process. This we have already used, but this is the detailed reasoning, and also two things. One is state, and there must be a difference. Two states are only one state. How we shall get a delta with one state? We are used to consider delta G for state 1, state 2, but when it is one single state, how? G product minus G react at the same state. What is the product free energy? What is reactant free energy? They are different. That is the delta. This is about a state 1. So these two use. Now important things. So I actually want to remove this. Okay. I hope not bad. These figures are very important. So I actually want to work here. This is very important. So I have removed this criterion, but I think I will get back to this. I have removed this. Anyway, I'll rewrite this. Rewrite this criteria, set of criterion starting from the second law, entropy of the universe. This I will consider. But let us write this 2 points. Please note these two more important observations. About the criterion. Let me write here. Criterion delta G less than 0. Delta G less than 0 and delta G PT less than 0. These two. Remember, this applies to, again repeat, applies to single state, applies to two states, change of state, two states. Still to this observation about the spontaneity criterion. This I am considering spontaneity criterion. Spontaneity criterion delta G, two spontaneity criterion. We got this. Okay. Now first one is characteristics. Sorry. A delta G less than 0. This criterion for this state, this criterion is more of universal nature. This criterion, and it is very fortunate, this criterion so it is not universal. This criterion is more of universal nature. Is more of universal nature. What does it mean? This, more of universal nature. That is, it applies. That is, it applies not only to a constant pressure and temperature process. Is it constant pressure, constant temperature? Not only to a constant pressure and constant temperature process or system undergoing a process, but also to other processes. Doesn't have to be constant pressure, constant temperature about this criterion. Then I will take up this criterion, but also to other processes. I think this needs rest. This pen needs rest. And this maybe put back. Okay, now start. So I think this is, but also to other processes such as for example, other processes such as one, constant volume and constant temperature process. You can use, no problem. As long as delta G is negative, so you are carrying this. As long as delta G as defined here, and you can remember what is GI bar? GI 0 plus R tail end activity, from which you get actually delta G is, recall, delta G 0 plus R tail end Q. So you can determine. Shall I write that? Delta G is, shall I write that? Delta G may be helpful just in case. Is delta G 0 famous? Hundreds of R tail end Q, recall. So anyway, process is not constant pressure, constant temperature, but constant volume, constant temperature process, or pressure to constant pressure and adiabatic process. Adiabatic means non-isothermal. Process. Third, tell me, third is constant internal energy and constant volume. That is isolated system. Constant process. you can use etc. etc. You can make constant pressure adiabatic, constant volume adiabatic, no problem, any etc. etc. But this type of actually here there is okay, very good, etc. etc. This is okay, very good. I shall remember any state at any state if it is a constant volume, constant or this or that or this isolated system, any state, if you have here negative, the reaction will be spontaneous at a state. You stick here. I'm talking of this. Stick here and state delta G. Find out delta G in that system is not constant pressure, constant temperature. Find delta G negative, spontaneous. Find delta G. Suppose it is 0, equilibrium. Find delta G if it is greater than 0, impossible. No, that reaction is not possible irrespective of the system. Okay, so this is more of universal nature. This you have to understand. Second is about the B. Second one. Shall I think I can remove this perhaps. I've actually now I have to remove this. This I've discussed. So, yes, that's fine. Etc. etc. B. What? Again another less than 0. It cannot be applied. This is for chemical reaction and confined to a state. Question must be properly whether at this state reaction is possible, then apply this, no matter what system. But reaction. But for example, it is a non-reactive system. Example, expansion or say rather compression of an ideal gas. Compression of an ideal gas irreversibly from state 1 to state 2. Compression pressure is final pressure is higher, P1 to P2, P2 greater than P1, compression. Then if you get not apply, because here you see delta G under constant temperature, isothermal process means only temperature constant, pressure will change. RTLN P2 by P1 for 1 mole. For n mole in RTLN P2 by P1, P2 greater than P1, so it is positive. But delta G, your criterion is delta G negative and your process is irreversible. So this is not for those non-reactive system, and that is we call fixed mass fixed composition system. They are this you cannot use, and probably you will not try to use also. Okay? But sir, two things I have said. This I will mention in, at the end. Okay? What is the most universal? Most universal, that is the end of this story. Then I will pick up from this point. This point I will pick up. Second, quickly. Second is delta GPT. Less than 0. Again, this is criterion. This, what is the limitation of this? Okay, this is actually this will apply. This will apply only for constant pressure, constant pressure process. Unlike very limited. If it is constant in volume, constant temperature, go energy. Here this. So it must be a constant pressure, constant temperature process. That is the limitation. You will often use constant volume, constant temperature. We often use adiabatic system, etc. etc. So, so what's all right? In contrast, delta GPT less than 0 applies strictly to the constant pressure, and constant temperature process. Constant temperature, constant pressure process, not any other processes. If you ask me, sir, suppose my process is constant entropy, constant pressure, what shall I do? No, don't use this. So what you will use? What is suitable or compatible? Correct? Correct state function? Enthalpy. I use enthalpy there. Impractical, not very good. Constant entropy, very difficult. But theoretically, enthalpy, constant entropy, constant internal energy, constant volume. What is the criterion? What is the parameter? Thermodynamic Helmholtz free energy. Like this. So BC is like any other processes. Okay. No. Now you might note here. Note we have incidentally the mixing process is a constant pressure, constant temperature process, and state 1 to state 2, and state 2 is the equilibrium state. So state 1 to state 2, we can, as long as it is within equilibrium domain, this domain, and this is this domain. So we have used this. GPT is negative, hence it is a spontaneous process, and we have established mixing is a spontaneous process. So this actually fits into this mixing problem. So right, note for the mixing process, write this a little bit, remove this. Note for the mixing process, that considered in equation 1. Yeah, equation 1 is the mixing process. Considered in equation 1, we have successfully applied the criterion for spontaneity as shown above. As shown above, it's a negative quantity. As shown above. As shown above. Note, now this is okay. The last thing is this. I will give you still another factor. Let me write this. I think enough is enough. Enough is enough. Remove this all. C I am writing. Just to complete this discussion. Criterion. Which criterion? Exactly what? And what it refers to what? In the last, right, lastly, we may note that general criterion. General criterion most general criterion, which is the original second law statement, which is the original second law statement, which is ds. I have removed this, starting with ds universe. Second law I wrote here, starting is ds universe, beginning second law ds universe greater than equal to 0, or delta s universe greater than equal to 0 is equal greater than for spontaneity, 0 for equal sign for equilibrium. or you may consider irreversibility and reversibility. Equilibrium reversibility, spontaneity is irreversibility, synonymous. So now this is universally applicable. No bar, no bar, no if, no but, no constraint. This is universally applicable. One problem is there, universe is involved. Normally we prefer system, that is, or maybe system. DS universe means DS isolated system. So that is, but otherwise when everything else fails, this will never fail, but this is the original. So this is universally applicable and universally applicable. This is universally applicable then. Wait. And applies to first I write, okay, one fixed mass, fixed composition system. Namely example, e.g. n moles of ideal gas. Oh, e.g. isothermal expansion of e.g. n moles ideal gas and n moles ideal gas, and if you and the process maybe, okay, what shall I write here? Applies to osmosis composition system like okay. I don't have to write so much thing. Like different processes, isothermal adiabatic with fixed mass be like n moles of ideal gas. Like n moles of fixed mass and fixed composition. Like n moles of an ideal gas. Undergoing a isothermal process. Recall this isothermal process. Recall this isothermal expansion of ideal gas or compression, etc., or constant pressure heating, or constant pressure cooling, constant volume heating, cooling, or compression, etc. So you apply this and this one. So fixed mass fixed composition system. Then of course, second, I think I don't want to take risk here. Okay. Actually, I am removing this line. This already understood, and we are almost last line. So maybe I am giving double star. So many double star. Just it will be completed here. What is this? 1, 2 is what? You can apply this delta is universe greater than 0 here, which you cannot. This system cannot be applied here. not to speak of this. Okay, here two things are constant. Okay, so neither here nor there, and so position then chemical reaction systems like A plus 2B goes to 3C. Chemical reaction system. Third is what? You can apply. Third is what? Mixing systems, or what should I write? Mixing systems. Okay. Mixing, or third is what? Chemical reaction system. Oh, I'm sorry. It is mixing or solution system. We are discussing solution. So here also chemical reaction I have shown. I have not. This can be applied. I have used delta. Delta is inverse. Greater than 0, equal to 0, less than 0. Chemical reaction systems or solution systems, as we are discussing currently. Systems. System. Right in bracket. Mixing process. What is the process? Mixing process. So all clear. So with this, actually this part of discussion is over. Next I shall take up what? I shall take up, actually I will start from this part, about the criterion of equilibrium and spontaneity in many different forms discussed. This one you dissociated into carbon and carbon dioxide. Recall this, see the assignment. This was discussed, and this misleading thing was given, whether the process will be possible, because but that process would not be possible because it was final state had gone past the equilibrium state, was post equilibrium state, so not possible. Assignment number, okay, I don't remember, or practice problem maybe. So with this, now I shall remove all these things. Okay, let us start removing. Removing this and make some room. I think these are actually, what should I write from the top better? Yeah, gradually remove this. Gradually remove this. Remove this. Remove this. Remove this. Remove this. Confusions all remove. Hence, just maintain this. Maintain this. Remove this. This. That's it. That's it. So we have now enough. Quickly. So what is missing here? Please follow this. This we discussed already. Na moles are tail in Na, and noting that activities are less than 1. So delta Gm is a negative quantity. Hence the mixing is a spontaneous process. I have given explanation how it is applicable. Okay. So next. Okay, equation, note this equation, what should I say? Equation 2, rather 3, equation 3, next, note equation 3, this is the final one, delta Gm, which is the delta G process also. Mixing is not a different thing, we are still in the process. So we are continuing with the same concept. We have not changed anything, but since it's a mixing process, we have given the term superscript M. Remember, this is the change of the system from. So note equation 3 applies to solution. We have not specified what type of solution it is. It is a mixed state or solution state. It is a mixed state means solutions. Solution state. Mixed state means solution state. State of, when you solution, I have written perhaps here as a solution AB. Mixed state means solution. I don't have to write this, already written somewhere. Solution. So applies to solution. Which type of solution I have not mentioned. So what applies to any solution, any type of solution. What are the types of solution? You know very well. That is, this is any type of solution. Ideal solution first of all, or deviation, positive deviation solution, solutions having ideal solutions, solutions having positive deviation, showing positive deviations from ideality, and solutions showing negative deviation from ideality. This type of three things we can apply, but ideal solution is a very special case and very nice reference. So we'll spend time on ideal solution. So let us consider ideal solution. Let us consider the solution as an ideal solution. Ideal solution means what? You know very well, which follows Raoult's law. Which follows Raoult's law. Raoult's law. Recall, what is that? So what is that? AI activity is mole fraction. Recall this. Components of which follows Raoult's law. Components of which follow Raoult's law. What is this? AI is xi. Apply this. So from equation 3 straight into this, from equation 3 quickly, very quickly. Delta Gm, now we actually into the delta Gm, what is the free energy change for ideal solution, and then we will consider other factors, entropy change, enthalpy change, etc. So from equation 3, delta Gm, tell me what it is. Delta Gm, see delta Gm prime Pt. This is for, remember, N1 plus Nb, never forget. Delta Gm Pt, yeah, is what? Achha, I am coming to this first of all. Achha, first of all, you do this equation 3. Achha. Let us consider the solution as an ideal solution. So ideal solution. Achha, rewriting equation 3. This is rewriting equation 3 or just no, it's okay. Let us consider that as an ideal solution. Achha. So from equation 3, putting, since ideal solution, A is XA and AB is XB. Okay. So what you are getting? Write this. Delta Gm prime Pt, happy, is what? RT Na ln XA. A is XA plus Nb ln XB. Okay. This is. Now this is for how many moles? Can you tell me? See here, Na plus Nb. For Na plus moles of solution. Once more write. Extensive property. For one, now divide this delta Gm prime Pt by Pt by divide by, then it will be for 1 mole. This is for 1 mole. So this is known as simply delta Gm Pt. That is, what is this? What is the name changes? You are dividing. What was the name? Integral total. One more. So molar. Integral no more total. Integral molar energy, free energy of mixing. Gives free energy of mixing actually. Free energy of mixing. And what it will be? Write nicely. RT divide by Na plus Nb both sides. Na by Na plus Nb. ln xa plus Nb by Na plus Nb ln actually this is over. Mixing is a mixing process is over. ln xp. What it is? Recall Na by Na plus Nb is the xa is what? Shall I write? Shall we write here? Right here. RT. This is xa. xa ln xa plus xp ln xp. Okay, this is the result. This is, so you box this, you may box this is the result delta Gn integral. Okay, this can be arrived alternatively. You consider this. You consider equation 2 somewhere. Yes, you follow this. Remember, this is for 1 mole, right? This is integral molar free energy of mixing 1 mole. Molar means 1 mole, so it is intensive. And this is the format. What is the difference? Na has been replaced by Xa only, and activity, since it's ideal solution. I've already started using ideal, so activity is no longer simplified as Xa. And AB is simplified as Xp. So alternatively, you follow this equation 2. Follow alternative from equation 2 this result. Shall I give it this thing? I give this thing. One result important. Alternatively, I will show you here. You follow this. Alternatively, how will you arrive here? Delta Gm is what? Tell me. Delta Gm prime Pt is what? What you see? Just see this equation 2. I'll write. Refer to this. Na Ga bar m plus Nb Gb bar m. Happy? Right? Equation 2. Now again, similarly divide by Na plus Nb or delta Gn, right? Similarly, m prime Pt divided by Na plus Nb is what? Again, similarly, Na by Na plus Nb Ga bar m plus Nb by Na plus Nb Gb bar m. Happy? I should not go. Okay, is start this, or you can start here, or delta Gn prime. Delta Pt, delta Gn prime will be out because it is for 1 mole. Na plus Nb, delta Gn Pt, exactly the same here, divided by Na plus Nb. So again same. This exactly this integral molar free energy of mixing at intensive. So this is what? Na by Na plus Nb is what? Tell me, this Xa. This is what? Xb. This Xa Ga bar m this we try to follow. So delta Gm 1 mole for 1 mole molar, it is what? Xa Ga bar m plus Xb Gb bar m. This is the value. Oh, so this I have given. What is Ga bar m? Partial I have written somewhere. Partial molar I have written, but I am writing it. I have written. I cannot avoid. partial molar free energy of mixing of A, and similarly partial molar free energy of mixing of B. So I should not write delta GMPT. Delta GMPT is okay. So you follow this, and you see two logics. When it is for NB moles, for Na plus Nb moles, it is Na Ga bar m plus Nb Gb bar m, and this is what it is Xa Ga bar Xb, because Xa plus Xb is 1. So Na replaced by Xa, Nb replaced by Xb. Remember, Ga will show up here also similarly. So there only Na will be removed by Xa, Nb by is molar value, and when it is total value, they will be as shown. Na and Nb will be there. So this is, and then can tell what is Ga? Tell me. Ga bar m. If you follow this, Ga bar m is here RT ln A. RT ln A. So write this RT ln A plus XP RT ln AB. So now what is A? For ideal solution we are discussing top ideal solution. Remember, this is the for ideal solution. So you can write here. You may write when you have applied ideal solution where sorry, here you have applied ideal solution. See here A has been written as Xa, putting into equation 3. So either you write here for ideal solution or maybe ideal ID. Similarly, these are all everything is ideal. From this actually everything is coming. So delta Gm prime just ideal, or you may not, if it's too many things here, crowd for ideal, like as I have written here, for an ideal solution is up to you. Ideal ID. So here also ID. This is also ID. Ideal. Integral molar or integral total, extensive, intensive, ideal, all the same ideal. So ideal is what? Why it actually start me activity of A. Ideal solution is X and AB is XB, and this gives you the same result. Is okay. Shall I write here? Yes, write here. Tidy up. RT in common. Xa ln Xa plus, oh sorry sir, sorry, plus XB ln XB, same result, the same result. Same result here, this same. So if follow, that is how to get, this is the integral value, how so partial, integral partial, this partial. What is the contribution? Xa, the mole fraction of A is the contribution, XB is the contribution. If it is not partial, then Na will be the contribution and Na will be the contribution, Nb will be the contribution, and total moles will be Na plus Nb. And here total mole. So this is one. Now actually it is time to gradually remove this. Now I am remove this. This part is all over. I don't need at all. So remove this. Not at all. Only this should be there. Nothing else. Now we will discuss other properties. Same result. Start from this. What is the thing? Next I shall so consider integral or property ideal solution. Ideal change. Okay, now it will go on with the ideal property. So one is the ideal solution. Next is, tell me what? Delta S M ideal. See, is it delta Gm ideal? Again, constant pressure temperature. That you keep on doing this. Delta is ideal, constant pressure temperature. Or sometimes we don't write in short. Is this delta Sm ideal in short? but you can give this. Okay, what is this? How do you get entropy? So this is one property, and now how to get this property from this property? From free energy, how you get entropy? The standard rule is what? Recall dg is vdp minus sdt. So how shall I write? Show you here. I'll show you. Minus ddt. Tell me delta gm with negative sign. Dg is, I'm just showing you quickly. Dg is vdp minus sdt, and dg is sdt. What is minus? S is minus dg del g del t at constant, del v del t at constant pressure. Constant pressure, if constant pressure, this will be vdp will be g. Okay, so you know this. So do this pressure, and not, but here also composition. It is actually fixed mass fixed composition, but this is a composition. Okay, system has composition xa and xb, so this cannot be changed. This for fixed composition. Here also make it that. This is for fixed mass fixed composition relation. So that's why fixed composition. Now what it means, quickly follow. You have found delta Gm. Say for example, what is the meaning of this? At a certain temperature, say 500 Kelvin, with a pressure say 1 atmosphere, with a composition, some composition you have taken. Say Na moles is 3, B and B moles is 4. So mole fraction is composition is what? 3/7, 4/7, like this. Okay, or say 3 and 7, say 3/10 total. So 30% and 70 mole percent. Mole fraction wise 0.3, 0.7. So that is the composition. So that anything. What you will do here? Nothing change. Only T. One set of experiment or one experiment. Then repeat 600. Otherwise same. Just repeats, only this temperature is changed. 500, 600, 700, 800, 4. Then plot these different values of delta G that emerge. Plot and then take the derivative. This is the significance of this. Okay, very important. So these are unchanged. If this I don't know. Cancel. So delta, this big relation, shall I write for you? ddt. What is the delta Gm? Tell me. RT, third bracket, quickly. RT xa ln xa plus xb ln xb. So again pressure composition. Shall I write here somewhere? Pressure composition fixed. Composition fixed means xa xb all fixed. If you take a derivative with respect to temperature is the only variable, and the rest is fixed. So minus r ddt of t is 1 minus r xa ln xa plus xp ln xp. This is the result. Write once more delta Sm ideal and box this by all means. So by this is one property, free energy, entropy. What is the name of this? If I ask you, similarly, integral, tell me, integral, and this is molar for 1 mole. Okay, molar, integral molar for 1 mole. Actually, say mole fractions are showing means molar. Instead of free energy, entropy of mixing. Okay, right? 1 mole. In the molar is 1 mole. Intensity. These are all intensity. This is the one. Second, entropy property similar. Acha, by the just curiosity. Positive or negative? Remember, x is what? Less than 1, and log of xb is also less than 1 and negative, and this negative and minus is a positive quantity. A positive quantity. Note this, important. Okay, now this you came across previously, recall. Yes, statistical thermodynamics. We showed that this is actually a what type of? According to statistical thermodynamics, this is the, tell me, same result. The result that you obtained, we have obtained here same, full agreement, exactly same. And we also mentioned that it will be obtained from the classical, today is classical thermodynamics. So according to statistical thermodynamics, which we have discussed, statistical thermodynamics which we have discussed, which we have already discussed, this entropy change is, this entropy change is what, which nature, either thermal or configuration or mixture, partly thermal, partly is configurational entropy change. Configurational entropy change. Just go back to my previous class and check entropy change. Okay, so this is second is, now what left, free energy gives free energy over entropy over enthalpy. Enthalpy, shall I remove this? No more needed, all should be removed. Only this figure you maintain. Sorry, this delta G, I should not, delta G, sorry, this should not be removed, this should not be removed. This is delta Gm, tell me what? Oh, sorry, delta Gm ideal. Is okay? Delta Gm ideal is RT, etc. This is 1, this is 1. Okay, this is integral molar. Okay. Now the second is enthalpy. What is enthalpy change? Recall delta Hm ID. Similarly, constant pressure, constant temperature, keep on, no problem, is delta Gm ideal plus T delta Sm ideal, constant pressure, constant temperature. Take a look here. This is what? RT, quickly write RT, XA ln XA plus XB ln XB. And what is this plus TS? T delta S is what? Tell me. Minus RT, XA ln XA plus XB ln XB is what? Is 0. What is the significance of this? No enthalpy change. For this process, no enthalpy change. Means initial state, these two species together have some enthalpy, and after solution, in the final state, same enthalpy. So 20 joule, 20 joule. Acha. But another interaction, heat interaction can be related here. Heat interaction, very practical. Heat interaction, recall what is the heat interaction? Use the symbol Q. Under a constant pressure, what is Q? Recall delta H. Remember, of course, there is another condition, but this is not mentionable here. What is that? This doesn't apply. This is under constant pressure and no non-mechanical work, but there is no provision of non-mechanical here. Okay, no electrochemical work or such thing. So no, so that is absent. So Q is delta H is what? 0. If Q is 0, what does it mean? No heat interaction between system and surrounding. That is, no heat interaction between system and, it's a system and this surrounding. No heat either coming into the surrounding or going from surrounding into the system. No heat interaction. That is no heat interaction. That is, the mixing is neither endothermic, sorry, RT ln XP here, RT ln XP, neither endothermic or exothermic. Or in other words, heat will not pass from system to surrounding, neither from surrounding to system. So 3 important. So that, right here Q is this also box, this very important. So 3 things, 3 major things over. Now what remains? Internal energy of mixing and volume. This I will find out here. Okay. So this where shall I write? Where shall I write? I'll write here. I remove this. I remove this. No use of this. In case you are interested, I'm giving you one by one. This is A. This is A. 4. This is the second B. This is the C. C. Now D is coming. What is delta upon mixing? If the volume changes, so it was initially 5 cc on mixing, it will be more than 5 or less than 5. Nothing. Let us see. Ideal. What is this? Achha, by the way, where shall I write? What? Where I write? Okay, delta G. It's okay. You know this. What is volume? How to get from free energy? From free energy relation, how to get volume? Recall dg is anytime. What is volume? You know, del G d delta Gm ideal. V is del G by del P at constant temperature. Apply that. Write this nicely. Id by dp under constant temperature and composition. Please tell me, what is this under constant temperature? Temperature is constant and composition is constant. So everything is constant. So what is the value? dp. Again, I carry out experimentally. How to carry out? You here pressure is the variable. Only one variable. Okay, this is actually not independent. So pressure. So what? You don't change composition. Don't change temperature this time. No temperature composition. Same thing repeated only with change in pressure. So first time is 1 atmosphere. And get the idea from this. Okay, these are the relations experimentally find. Then change to atmosphere. Second result. Third, fourth, fifth. So 5 set of delta Gm ideal against 5 pressures, and then you will of course ideal. If it is not, then you will infer that it is a non-ideal solution. No, don't worry. So this is over. Okay, this is again just last is what? Internal energy. Delta Un. How will you get delta Un? Recall H is U plus PV. So I am writing delta H, again delta H M, right, full M ideal. Okay, PT, you can give on PT every time. PT, your process is constant pressure, constant temperature process. Okay, so every time constant pressure, but that constant pressure, this, okay, constant pressure, find this. Like this here, constant temperature. Temperature is changing all the time, but temperature. Okay, so this is done. But delta U, delta H, EM plus, thank you, plus, okay, do this, delta U, delta minus, delta PV, PT, 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 okay, delta is what, how much it is? Tell me, pressure constant and volume also, no change in volume. Volume is also delta PV. No, it is also delta Vm is P or right here, constant pressure, so right here, delta H quickly. M ideal minus P is outside, constant pressure, outside, delta V M ideal. Okay, what this value is 0 and this value is 0, so 0. So this is another important observation. What you will give name to this? This is another, still another. This is ABC, this is D, this is E. So these are the results we obtained. So we will actually stop. We will take up actually the next lessons. Okay, where we will sketch okay, and enthalpy next day, and also some phase diagrams that is compatible, that is actually that conforms to this behavior of positive deviation and negative deviation ideal solution. Thank you very much for your cooperation and for your patience. Okay, see you. Okay, goodbye. See you next day.